So here's our car. As you can see, it looks a little different. But we've got a vehicle. Customer concern is the ABS light is illuminated. Service ABS message is displayed. So I'm going to go ahead and verify the customer concern. I turn the car on, and as you can see, it's TCS off. That's the one warning light, and then the anti-lock brake light is on. So I could go ahead and do a road test. Here's the brake. Brake lights work. I can go ahead and speed up. The car drives fine. I can go faster. 30-something kilometers here. And when I slow down, everything seems to operate normally, which makes sense because the tip is if your ABS light's illuminated, you have a code, your regular brakes are still going to work. So you're still going to push the brake pedal, you're still going to get brake lights, you're going to get hydraulic pressure built up from the master cylinder, it's still going to stop fine. The negative is you're not going to have any ABS. So if you jam the brakes really hard and it starts to lock, let's say this left front up, it's just going to stay locked. It's not going to do any anti-lock activity. So as you can see, it's indicated crash, because we have no ABS. So the first thing you do if you experience this is check for codes. So I've already got the scan tool set up. It does have a regular DLC, just like a car. And the other thing you may do is just do a visual. So that's, you kind of have a judgment call here. One, if that light's on, you got codes set, so you do want to know what codes are set. But two, you should probably at least do a visual inspection. So you got to pick one. Check the codes, then do the visual, or do the visual, then check the codes. But your visual inspection should focus on things that could set the codes. So like, as an example, if it's like an ABS code, you're probably kind of looking at wheel speed sensors. So you'd lift the car, look at the wheel speed sensor. We've seen many a times where the wheel speed sensor harness is cut from road debris or damaged, in a number of different ways. So we've even seen rodents chew stuff, so do a visual inspection. The sensor's installed, the sensor's connected, the harness, right? I don't see any visual issues here. And then I would check codes, or maybe the other way around, like I said. So if I go ahead, connect the scan tool, get to the menu where I'm ready to check codes, I'm going to go for current codes. I don't particularly care about the history. All right, so I've got two DTCs right here. I'm going to focus actually on this one in black, the C1234, left rear wheel speed sensor circuit open or short. So that tells me something. What that tells me is this is the ABS module right here. They can have a lot of different names. In this instance, it's electronic brake traction control module, EBTCM. It could be the HCU, hydraulic control unit. It could be a skid control ECU. They have a lot of different names, but ultimately in the system, there is going to be a computer, and the computer is going to be getting signals from the wheel speed sensors. So the wheel speed sensor sends the signal through the harness to the computer of different types. So for this one, let's just call it the ABS ECU. Cool. So I know that the ABS ECU is able to detect there's something wrong in this circuit. But here are the shortcomings of the ECU. Basically, I could draw it if you really totally want to understand it, but it's basically got two resistors, one internal resistor, and the sensor functions as a resistor. So when it monitors a voltage, it's going to basically be able to predict how many volts it should have internally. So let me show you what that looks like. All right, so here's your circuit. You got the ABS module. It can use 5 volts as a reference, or it could use 12. You could technically use any voltage that the engineers deem they want to use. But if you got 5 volts coming through, it's going through a resistor, that's going to drop some amount of voltage. And then some amount of voltage is going to be left to drop through this, which is the wheel speed sensor. That's why it looks like a variable resistor. So that's kind of the simplified answer, but that resistor should have some resistance. So let's just say this is a 10,000 ohm resistor, and this resistor down here is, let's just say 20, because that would be within spec. That would mean this should consume double the voltage than this. So this may be consuming, let's say, 3.5. If this is going to consume 3.5, and this is going to consume about 1.25, and that would get us pretty close to the 5 volts. That would mean after this resistor, we should have essentially like 3.75 volts right there, right? And then we'll drop the 3.75 or so right here. So the way that the ECM does this is it uses a little sense circuit right here. This is just called a voltage divider. It's going to put a little circuit in its circuit board that's going to do sense. And it's expecting, like we were saying, maybe like 3.5 to maybe like 3.75 volts right here. Just based on the math of Ohm's law, right? This has 20 kilo ohms and this has 10. So therefore, there should be about 3.5 to 3.75 or so volts left over. If on this sense circuit, it shows, let's just say 0 volts, that's out of range. So the threshold there of 3.5 to 3.75, it's out of the threshold. It has 0 volts left over. That's why it sets a code. It knows there's something wrong in the circuit. The only reason it would have 0 volts right here is if there was, like, let's say a short. A short to ground would cause 0 volts. So this is connected to the ground. Or let's just say it has 5 volts. It's probably a little bit more likely. If it still has 5 volts left over, that means all the voltage is passing through the first resistor, probably because this is open. Right? So if we had an open here, that would have 5 volts at this sense point. Technically, it'd actually have 5 volts here, by the way. But essentially, if it's showing a high voltage, that means we have an open somewhere downstream in the circuit, like where I had it. All right, so that's important to know, because when this code sets, you don't have to worry about checking the brake pads and checking the rotors and stuff. So back on the car, you now know, based on that circuit open code, it's a problem between here and a problem between that left rear. That's the one we're going to focus on. Now the circuit problem could be the sensor itself, because we're sending a reference voltage in through an actual winding that's here and then back out. So the winding could be open inside the sensor. It may very well be a sensor. Or it could be the red wire, or it could be the black wire, and it could be anywhere between the sensor and all the way back to the ECU. It could be a connector, like a terminal issue at the ECU. You see, I already have a couple things pre-probed to make this video go quicker. Or technically, it could be in the circuit board of the EBC, well, we'll call the ABS unit. Let's call it the ABS ECU could have an internal, like what we are showing on the board here. If I have an open here, that causes 5 volts to be at that sense circuit. You could replace the sensor, you could replace the harness, you could replace all sorts of stuff. The issue may very well be in the circuit board itself. So the shortcoming of the onboard diagnostics system is it doesn't exactly know where the problem is. I just proved it to you. This is how it does a diagnosis. It doesn't know if it's in the circuit board in the ECU, doesn't know if it's in this part of the wire, in the sensor, in this part of the wire, or it could even be all the way up to potentially that ground, although that would, we wouldn't get 5 volts if we would get 5 volts if the ground was open. Actually, it's exactly what we would get. So the problem, it doesn't know where the problem is. That's where we come in. So the first thing I'd probably do with this is I'd probably try to clear the codes just to see, because if it's an intermittent issue, we're gonna diagnose it one way versus the other. So let's back out and let's do. We'll jump back in there and we'll just try to say clear codes. Now take a note, write it down. You can check the freeze frame if you want, because once you clear the codes, all that record is gone. All right, codes are cleared. Very nice. But I still have a light on, so I have a feeling it didn't fix it. Let's display the DTCs. Current again. Oh, interesting. No codes present. Let's see. Oops. Okay. Wow. All right, so after a couple key cycles, I did get one code back. Looks like that left rear resolved, but we remain with the left front. So I'm going to focus my diagnosis on that. The way that I would most likely proceed, because I've already tried to clear it and it came back, I'd probably jump out of here and I'd go into data. So in this one, it's data display. Now that way I can actually see the sensors themselves. I'd really like to see what that sensor looks like. So for example, here's our left front and right front. I'm gonna drive the actual car. As you can see, my wheels are turning. All right, so now you guys can see we've got the left front wheel. You can see we've got the right rear wheel. Nice up and down. We can slow down here. But you'll notice the left front was flatline. So clearly that has no response. So we should definitely focus on that left front. We know it's not working, we just don't know why. All right, so to further track down with that harness, we really need to measure it piece by piece. So let's say, for example, if we're troubleshooting this sensor and you're really DIY and you don't maybe have all the tools, this left front sensor is most likely the same electrically as the right front sensor. So now the length of the attached cable may be a little bit different, but electrically the same. So if you really are struggling, you could swap left to right, clear the codes, see if the code remains in the same spot, or if the code was the left and now it's the right, you know it's that sensor because you just moved it. But that's not really my role in training, so I'm going to go a little bit more proper as to how to diagnose this. And depending on how accessible this is, because sometimes these wheel speed sensors are attached to a cable that goes all over the place and up above the fender liner, they can be a little bit tough to check, to access, because we actually need to access these terminals back here and check their resistance. It's going to be the best way to proceed. The other thing we could do, like what I started to do here, you could actually probe them where they're at the ECU. So one or the other, and I'm going to take you through starting over here because I think it's the most logical. And I'll be using these, they're basically like T-pins, but they're little probes. They're very small, they're not real invasive. We're not going to pierce the harness. We're just going to simply slip our way in through the seal. So let's say I do that right now. I'm going to slip in through the seal. Not even cutting the seal, just inserting until I hit the metal terminal, which I feel like I've done. So now I'm connected to that while it's connected. Other thing you could do, if we're just trying to check the sensor, is you could pop this connector off. Just fighting me a little bit. And if we're just trying to check the sensor, you could try to hit those couple terminals in there. You can barely see. Put my light on those. So you could go to those two terminals and check the resistance. But I find it easier to keep that connector right on there and back probe it. With these connected, I'm getting about a 0.695. So this is a little bit of a challenge on this vehicle because normally we'd very simply go and pull some specs and get a range, but this is partially a car and partially a trainer, so I can't get the exact specs. But what I can do is I can pick another sensor. So if it's the left front, electrically, the right front sensor would be the same. Now, they may have different harness, like these are pretty simple. They plug right in the sensor, but a lot of times they'll have a harness attached to them, and you'll actually be back probing way over here because the connector is on sort of like a foot or 2 foot long pigtail. But electrically, they'll be the same. The front to rear may not be the same. But on this one, I know that they are. So I'm actually just going to jump to the left rear because it's a little easier to see than the other side. So I'm just going to do the same. Probe on here. If you have access to the specs, you do not need to do this. You would go by the specs. And exactly which one's red and which one's black doesn't really matter. Let me get these probed nice and next to the seal, but not cutting it. So the thing is being it's a little tough to do the back probe. So I'm going to show you a cheat trick. It's actually, this is a trainer, so it's made for me to be able to test the sensor here. So I'm actually just going to use that. So here's my number, about 0.894 kilo ohms. So basically, I'm going to give this a range, and I could check all of them, all about the same, of something like 700 to 900 would be perfectly normal for the wheel speed sensor. So now that I have my spec, I'll jump back up on that upper one, which, because we're really testing this one, I'm going to put in the extra time to make sure that I get it back probed. I can prove it to you. I could very easily do that right there, by the way, for your benefit. So there we are. As you can see, about 700. It's a great reading. So based on this, remember, all I'm doing is I'm sending electrons in through the winding of the wheel speed sensor and back out. I'm only testing between the leads, which is just the sensor. But that's a pass. Remember, our spec being about 7 to 900 kilo ohms, or 0.7 to 0.9 kilo ohms. So the sensor's good. What that means is if you were to slam a sensor in there, it wasn't going to fix it. And if you were to do it janky style and, let's say, switch these two, take this one, put it in here, put this one in here, the DTC would be solved for this one, but the DTC would now be for the right front. So you could, that's one way to do it too. Probably a lot more work. And if it doesn't follow it, like in this case, it would not have followed it. Now you're still stuck with a problem here. It's not the sensor, so it means it's either in this harness, one of those two wires. But remember, those go all through the car, all over, and they end up at the ECM or the ABS ECU. So the circuit could be the winding and or connector in the sensor. Each of these two wires all the way over here, it could actually be a terminal issue here. Or remember, they go into that ECU like in our picture. The problem could actually be in the ECU circuit board. We don't know. If you jump to the ECU circuit board and put an ECU in, it doesn't fix it. That's a lot of money though. So let's narrow this diagnosis down. Now that we know it's not the sensor, that's what I would do next. If we probe over here at the ECU, it's going to do essentially the same thing. It's going to send voltage in through the winding and back out and measure how difficult it is to go, because it uses its internal 9-volt battery when it does that resistance measurement. I could take those and I could probe them over here on the same two wires, and that's going to send voltage all the way through and see how difficult it is to get all the way back. But I'd have to know which two wires. So remember how these are yellow and white? Well, I'm going to look on the wiring diagram and find out where they are on here. All right, I looked them up. It's terminal 24 and 8. They're the same colors. If you look, we're probed here on that yellow. And down here, it's going to be much more difficult to see, but it's on a white. If I light it up, yeah, you still really can't see, but you can trust me. It's on the 24 and 8. In our reading, oh, that's not a good reading, right? We were at 0.7 kilo ohms, and now with the wires included in the loop, we're at 47 kilo ohms. That's way too much. It should have been 0.7 here and maybe just a little bit more than 0.7 here, just factoring, a small amount of resistance added by the wires. So this is a fail. Now the problem is, I still don't know where the fault is. But, in some instances, I'm good to say, hey, customer, you need a wiring harness because I know it's in the harness, right? Right now, I'm checking the harness and the sensor, but I already checked the sensor, so I know the sensor is good. So, like algebra, I know that the sensor is good, so therefore I know that the wire is no good because the wire in the sensor is no good. All right. But I'd like to take it a step further than that because our next step would be tear the vehicle all apart, tear it down, and trace the wires and maybe find it, or just sell the customer harness, which I don't think is a great repair. I think actually offering a wire repair is in the customer's best interest. Going to save them money, and you can do a high quality. So what you'd consider, let's say that we had a connector right here in the middle of the car. We could actually do the same test down here, boom. And if it failed, we know it's on this side. And if it passes, we know that it's on this side. But in this car, there's no connector in between. So we're going to jump to, which wire is it? Yellow or white? I don't know. So let's leave this one probed on the yellow. Let's pull this one. I pulled the wire off the white and I went to the yellow on this end. So now I'm just basically measuring the resistance of just the one wire. All right, so now just again, because this is a trainer, no car is going to get back probed this many times. So I'm going to cheat off of the back probing and I'm going to go to the sensor. But this connection point is the same as this one, okay? It's just a little easier to access. In fact, I don't even need the back probe. This trainer was made for this. This is made for students to be able to learn. So I get the resistance of that yellow wire, and I'm actually looking at a 3.4 ohms. Well, that's not perfect, but that's a pretty good reading for just a wire. So I think the yellow wire is good, which means now, and I'm not even really supposed to be back probing here, but this is just for you, okay? You're special. Now I need to jump over to the white. It is that terminal there. So I need to jump over to the white. And then I need to jump over here. Okay. Oh, 27 kilo ohms. That is not a good reading. So that would be a fail. So I know my issues on the white wire between here and here. Okay, so now I'm going to take you behind the scenes. We need to repair the harness. Well, I can tell you where the harness is open because this has fault box. Ooh, open? How about normal? Okay. Hey, we like that. So now I just verified the harness is repaired because I repaired it and that measurement's a good measurement. But we should take this step further and I'm going to pull all the test equipment off. And just like how we verified it, we need to go ahead. We should clear the DTCs. Okay, let's go into DTC clear codes. And technically, a lot of times when you fix the circuit, it may have actually already cleared the code, but we're going to be thorough and actually clear the codes. Okay, continue. And then we can just check for codes immediately if we want. All right, and then bingo, no DTCs present. So probably the next logical step would be let's take the car out for a road test. Let's make sure everything is good. Get it up to speed here. And then we would go ahead and maybe just check DTCs one more time. Not going to have any because we fixed it. Make sure the light didn't come back on. And then get ready to write your story. So the way that I would write this story is something along the lines of verified customer concern, ABS warning light was illuminated. Check DTCs. DTC was, I forget the number, but C1232 possibly. Left front wheel speed sensor circuit open. Perform visual inspection. Found no visual problems with the harness and or sensor. Proceeded to perform specific electrical testing. Checked sensor resistance, terminal A to B at 0.700 kiloohms. Checked complete circuit resistance from ABS ECU terminal 24 and 8 found high resistance. Tested individual wire white from B to 8. Resistance was excessive. Determined open circuit or high resistance in white wire. Located open in that wire. Repaired wire correctly. Cleared DTCs. Road tested. Found DTC did not return. Customer concern has been repaired. Something along those lines with your own wording. But I personally would recommend being specific which terminals you checked and what your actual reading was throughout the actual testing. More details is better. So now I'll tell you a little more. This is based on an old car, and the way that it works is still kind of the same. The sensors are an input to the module, and then the module actually controls the isolation dump valves. So none of that's changed. But the truth is these sensors have been replaced. So I got just a quick explanation here. The sensor that we just tested was this type. It's a 2-wire. It is going to do, basically monitor the wheel speed, but this would be an even older school. This is another 2-wire, but it basically just generates its AC current off of the magnetic field that the sensor has. And then if you notice, this has a reluctor wheel that's going to turn. So I'm going to turn that on. When this reluctor wheel turns, that would induce an AC current into this sensor, and that AC current would be sent to the module, and that module will basically look at, how many volts and also how fast it's switching back and forth to determine wheel speed. So that's kind of old school, and they were unreliable unless you were above 3 miles an hour. So these are kind of gone. Then we went to this style, which is what we just tested, and they're actually the ECM is actually sending a reference voltage, and so that makes it accurate to low speeds. So we're going to most likely be doing active type sensor diagnosis on any car above like 2010. If it's before then, it may have active, but it may have like what we call passive. And these are pretty good, but we do have another type that's more and more common. So this is a 2-wire active sensor. We've gone to more commonly a 3-wire, and this is more of like a Hall effect style. So magneto-resistive to Hall effect. Hall effect is 3 wires. One of these wires is going to be sending probably 12 volts to run the DC Hall effect chip. And then one of them is going to be ground, and one of them is actually going to give a DC square wave. And what's interesting about these is they're active. They're accurate to low speeds, but what we'll also do on this type is we'll add one different tooth on the reluctor. So I'm going to bring it up to the top here. You notice there's a double gap right there. So that, if we have a gap in the teeth, that's going to become a position and speed sensor. And the way we diagnose these are a little bit different. It's similar in what we just did here as far as, the sensor needs 12 volts. Check for 12 volts out the sensor. If it doesn't have it, back up and check the ECM for 12 volts. Pointing the wrong one. So this is 12 volts to the sensor. Doesn't have it, check the ECM. If the ECM is giving voltage, in this case it's 5, so I misspoke already, but the ECM is providing 5 and it's not making it to the sensor, there's an open in the harness. So you can still do a lot of your diagnosis with the meter if the sensor is getting 5 volts and getting ground, and it's not producing any sort of voltage here. You probably have an issue with the sensor, but it could also be with the ring. Maybe something's wrong with the ring and it's not turning, or a bearing is loose and the ring is shifted and it's no longer in the window of the sensor. So a lot of this you don't need to go real crazy with, but an oscilloscope is mostly how we're going to see these in detail. So we could use an oscilloscope on this, but I just showed you like If it's a circuit problem, we can diagnose it. If it's a performance problem, that means the circuit is not, it's not a problem with the circuit not showing the correct voltage. It's more like you're going down the road and one of these sensors signals is kind of iffy. It's maybe going up and down when it shouldn't. That would be the sensor performance. That can be harder to diagnose. That could be, like I said, a loose wheel bearing. But I'm going to make a separate video on this using an oscilloscope, because there are times where just the meter will not be enough to diagnose it. The oscilloscope is going to give us a full image of voltage over time to help us determine, is it a chipped tooth, a broken tooth? Is it possibly an issue with the sensor? Is it maybe an intermittent loose connection where we're showing a wave and then we're dropping the wave? So this is going to be a little more advanced, but this is by far mostly what you would need to know. And then this is going to be a separate video. And then the other thing I'd like to point out is the sensors can look like this, but they can also be a magnetic strip that's being read off of a smaller type of sensor. And so this is a magnetic strip type sensor, just a lot smaller. And if you notice, this is actually the outer race for a wheel bearing. So if you don't see a reluctor wheel on the axle, doesn't mean it doesn't have one. It could actually be a magnetic strip in the wheel bearing itself. So overall, that's my lesson on wheel speed sensors. Part 2 coming up.